last video for this semester. I'm so happy. Sample means. All right, so 7.2 was sample proportions, and this is how the units 7, 8, 9, and 10 work. The first day is the nuts and bolts of what we're going to be doing. Then the second day is going to be proportions, and that's when we do percentages, you know, or they might just tell you proportions, but where you go. And then the third one is going to be means. Means is when they give you the average, like 17.5. 17.5 is the average number of shoes by IHS student. Instead of 72% of the students have at least 17.5 pairs of shoes. All right, the mean of the sampling distribution of X bar, the mu of X bar is equal to mu, no condition, just like we want it to be. But the true, and remember, this is the average of the samples. This is the true population average or population mean. The standard deviation is sigma divided by root n. And again, we have to have the 10% rule for this one here. And these are on the formula card again. But again, all you're going to do is you're just going to take the sigma they gave you and divide by the square root of n. That's actually pretty nice. And a lot of times they'll give us n as a perfect square. What is the shape of the sampling distribution if the sample is taken from a normally distributed population? All right, so if we take a normally distributed, if the population is normally distributed, our sampling distribution will also be normally distributed no matter what the sample size is. If it's not normally distribution in the population, we can still get a distribution for the sampling distribution to be normal if the sample size is at least 30. Different rules this time. All right, so at the Nutty Peanut Company, dry roasted shelled peanuts are placed in jars by a machine. The distribution is normal with a mean of 16.1 and a standard deviation of 0.15. Without doing any calculations, what's more likely, getting one that's more or one that's an average of 10 jars that's more? And the single jar is, because it's going to be easier to get crazy results or to get, you know, high variability from the smaller sample size. I don't know how you don't know that by now, but probably you did know that by now. Find the probability of each event. So probability of a single jar, normally distributed, mean of 16.1, standard deviation of 15, normal CDF. I plug everything in, get the percentage. Easy. For 10 jars, mu of X bar is the same. It's still 16.1. Sigma, you take the 0.15 and divide it by the square root of n, square root of 10. That one you don't get such a nice number. But now we have mu and sigma. We plug those in. Much harder. Again, look at how much did 25% of the time you should get one that's under 16. It's almost impossible to get 10 jars that average weight is under 16. Not impossible, but almost impossible. What is the shape of the sampling distribution with the sampling mean if that's not? Well, I kind of let the cat out of the bag. It's normal for sure if n is greater than or equal to 30. It's called the central limit theorem or the large counts theorem. Large counts, lost the word I'm looking for. Central limit theorem or the large count assumption or whatever. I don't know the word I'm looking for, so I'm just going to stop now. All right, so here we go. So now we got a problem. Suppose that a number of texts sent during a typical day by random selected high school students follows this mean and standard deviation. I bet you it's higher now. This is a 7-year-old problem. Assume that the students at your school are typical texters. How likely is a random sample of 50 students to text more than 1,000 texts in the last 24 hours? Now, this was per student. Also, I do like to point out, it says it's right skewed. But since our sample size was at least 50, then X bar will be normal. The distribution of X bar will be normal. All right, mu of X is 15, sigma X 35, and then sample size was 50. Right here, the average, that's 20 texts per student, right? 1,000 texts for 50 students, 20 texts per student. The average is 15. We basically want to know we need to be over 20 per. Okay, And then we define x, and I already did that part. Mu of x bar equals mu of x, which is 15. Sigma x bar is the 35 divided by the standard, the standard deviation, that's funny. Square root of 50, 4.95. And then again, we have to do the assumption that the population is going to be more than 10 times our sample size. So we use the trick, we just say, we're going to assume that there's more than 500 students to sample from. Now, independence, that's not much of an assumption, right? 500 students, that's not very hard. If you went to this little teeny school out in the middle of nowhere, that would have to be an assumption, because you wouldn't just assume that that's how big the schools are. But again, new mu, new sigma for normal CDF. Then state, do, conclude. Also here, 15.62%, not unlikely to happen by chance. Because at how likely is that a random students? Remember, we only have two. We have unlikely to happen by chance, not unlikely to happen by chance. All right, this last sheet, this is just notes. This is all of the symbols. I do not need to read all of these for you. There they are. And they're scanned and posted for you. I do want to talk about these down here. The average of the average is the true population average. The average of the sample proportions is the true population proportion. Those are very powerful, very important, very easy, and very much on your formula card. Standard deviations, or I'm sorry, shape. Shape, if normal, in order for it to get normal population, for the means problem, this is the means column, by the way, sample size must be bigger than 30. For proportions, you need 10 successes and 10 failures. So if the population is normal, you're good. If not, then you need these. If you use this for a means or this for a proportion problem, you receive no credit. And then the spread, again, these are given to you on the formula cards, and the condition is the 10%, the 10% rule, that the sample is less than 10% of your population. All right. Here endeth your semester 1 new material. Make sure you study for that semester exam. Chapter 7 only is covered on the semester exam. Double minor grade, no retesting. There it is. Y'all have a good night.